Okay, so welcome everybody to free session one. Um, Today we're going to be doing a quick little um, introduction to the different concentrations in electrical engineering. Gerardo, if you want to go to the next slide.
All right. Well, we should introduce ourselves.
Oh,
So,
but that's
oh, that's
okay.
that's
Yeah,
later on, huh? Yeah.
that's a different slide later down.
Oh,
So first off, IEEE. To reiterate, if you guys haven't seen the introduction video, IEEE is Institute of Electrical and Electronics Engineers, very large organization, professional organization with almost 500,000 members worldwide. And here specifically at the Long Beach campus, FREE, which is the Freshman Retention in Electrical Engineering, we're a subgroup in IEEE here, and we're focusing on freshman students in electrical engineering, transfer students, and also non-electrical engineering majors. Trying to give you guys a little bit more hands-on experience, a little bit more information than you guys would learn in your regular classes, and try and teach you guys some projects along the way.
all right. So, in
So
case,
yeah,
so
go
yeah,
ahead.
in case you guys haven't already, but I'm sure a lot of you guys came from the Discord, but we recommend that you sign up for the IEEE Discord because that's not only where you'll get updates for free, but in terms of the whole IEEE club in general. So we're gonna start having general body meetings soon. So if you're interested in those, information like that would be posted on our Discord.
So for the agenda for the whole semester, week one, like I said, which is today, we're going to be talking about the different concentrations in electrical engineering. Week two, we're going to start getting into the hardware components, resistors, capacitors, inductors, and all that type of stuff. Week three, breadboarding and building basic circuits. We're going to show you guys kind of like the image we have displayed here, how to put all the components together and the theory behind that, as well as we'll have some practical examples for you guys. Week four, we're going to go into the different instruments that electrical engineers use. You guys will be getting more familiar with them throughout your time studying electrical engineering here at Long Beach. But we're going to go over things like, let's say, Gerardo, what kind of, we're going to go over like signal generators.
For the instruments,
Yeah, for instruments.
so some of the things that we'll go over, like Dakota said, signal generators. We're gonna go over oscilloscopes, multimeters. What are other things that we've used?
Wave function generators.
Oh, like signal generators too. So though, if you, whenever we go back to campus, if you take a class like 211 or 330, you're going to be working with these instruments a lot, especially when you're building circuits. For example, let's say, I can annotate here. Let's say right here you have this circuit and you want to measure the resistance between, or you want to measure this resistor for some reason, like you just don't know what the resistance is. You can use something like a multimeter and just connect the probes right here, and that instrument will help you read what that resistance is. And also you can do things like reading voltage across the resistor and what the current is across the resistor as well. So we'll get more into that later on in week 4.
Yeah,
And
we'll
then,
also go over soldering too.
yeah, and then week 5, we're gonna go over some programs in electrical engineering. So some of the things you might encounter is some of the languages you might encounter is like C, definitely MATLAB, and definitely like programming in Arduino. And then in the end, we're gonna go over our parking sensor project. And it won't be too crazy. We'll talk about it a little bit more in this presentation too. So we'll go into that later on. So who are the mentors? We have Elmer Salinas. He's currently not with us right now, but he's also an electrical engineering student. His concentration is on electronics and power. I guess some fun facts is he's too scared to fight you in real life, and that's his pet giraffe. And then there's me in the middle, Gerardo Sanchez. I'm also electrical engineering major. My emphasis is in control systems, and I guess I look better in person. I don't know.
Last one is me, Dakota Navarrete. I'm also control systems and power systems, double emphasis. Um, that's something I'd recommend you guys if you're interested in them. You can do them pretty easily. It's just I think one or two extra classes when you get to the upper design classes. So it's definitely well worth it. I like to travel, enjoy outdoor activities. This picture is me over at Bonneville Speedway in Salt Flats.
All right, so like I said, this is a project that we'll be having for this semester, and it's a parking assistant. So we decided not to do anything that would have been too crazy because everything is remote right now, and we don't want to stress you out with an extra project, because really the point of this is just to get you to start working with hands-on experience with like circuits and programming. And I think purchasing an Arduino right now would actually be kind of cool, especially since we're all at home. You can just work through all these little projects, and when you get back and then you start doing more hands-on labs, if you're not doing them right now, you're already going to have that experience of like building a circuit or programming and having to integrate it with your Arduino here. So some of the parts that we're going to use, they're affordable and they're easy to find. I'd say the only kind of expensive one would be having to buy the Arduino, but the Arduino software is actually free. And if you buy a kit, you can get tons of sensors. So in this case, we'll be using the ultrasonic sensor. We're going to use a couple LEDs and two 220 ohm resistors and some jumper wires. But like I said, if you buy a kit, typically everything that we're going to use here is going to come in that kit. And the kit's also going to provide you with a bunch of extra stuff that you can just use on your own time. And like I said, it's pretty cool and it's pretty easy to like build a bunch of different little projects. And I think just getting started and doing stuff like that is like really helpful.
So what is electrical engineering exactly? In broad sense, it's the discipline concerned with the study and design, as well as the application of equipment, devices, and systems that use electricity or electronics and the theory of electromagnetism. So there's numerous concentrations in electrical engineering. I believe there's 5, if I remember correctly. Now, according to Bureau of Labor Statistics, the median pay for electrical engineers is over $100,000. And the job outlook in the field is 3%, which is kind of average, but I would say that that's typically when you look at job outlook, that's the growth over a certain period of time. So the increase in the amount of jobs in that sector. And I would attribute that being pretty average, not to that there's like not a very high increase in jobs in the field. I'd say there's always a demand for more and more electrical engineers, but just actually that not more and more people are actually getting into the major.
All right, so now we're going to start going into the concentrations that you can expect to see at CSULB. So one of the first ones is communications. So what would you do if you're concentrating in communications? So you research, design, and develop and test electronic equipment used in communication systems. That's pretty good. What you'll be working with is transmitters and receivers. And you can also be working with the forms of communication, such as wire, coax, cables, optic fiber, and even free space. Free space just basically means wireless communications. Some of the job opportunities that you can have with communications is telecommunications equipment engineer, network engineer, outside plant engineer, and information systems and securities.
So controls, both Gerardo and myself are controls. This is not the biggest major, but I'd say if you haven't decided your concentration with the major, I'd say controls is very interesting. So what do you do with controls? You model and design controllers that cause systems to behave in a desired and predictable manner. You use electronic circuits, digital signal processors, microcontrollers, and programmable logic controllers. That's all stuff that you'll learn later on. Job opportunities, you can look into automation, aircraft industry, manufacturing, and robotics. If you look on this picture on the bottom with the guy, he's messing around with this feedback system on this automated drone. So if you are interested in robotics, or if you like to work with your hands, controls would be the best emphasis for you, electrical major.
Okay, next we have digital signal processing. So what would you do with digital signal processing? You work with the manipulation and analysis of signals. Uh, you work with either analog or digital signals, and analog signals, the difference between analog and digital, if I remember correctly, is that I believe analog is a continuous signal and digital is kind of like just zeros and ones in a sense. So it's either on or off. And what you can work with is the amplification and filtering of different kinds of signals, and even compressing, error detection, or error correction. So some job opportunities that you can have with DSP, well, just in case you didn't know, we also call digital signal processing DSP, just to make it a little shorter. So some of the career opportunities you have with DSP is image and video processing, wireless communications, once again, seismology, because those are different signals that you're receiving in terms of vibrations in the earth, radar detection, and even speech recognition. Even with digital signal processing, from what I heard with some other students that I talked to, they go into music too. So I guess you
Yeah,
want to improve like the quality of what you're recording when you record music. So that's
yeah,
something you're interested in that too. It's pretty cool.
yeah. So I'd like to add a lot of people that go into this major. First off, you have to really like uh, working with a computer most of the time because you're going to be basically analyzing signals on the computer all the time. And a lot of people are very interested in music go into this because, like Gerardo said, you can work with audio amplifiers and making them better, making the sound quality better, being able to make the volume louder, different stuff like that.
Yeah, so
That's
like
all for
if you're
DSP.
thinking about like applications of DSP, like think about just like an electric guitar and you have all these different pedals and all of these things kind of distort the sound or make your guitar sound different. That's basically DSP. That's the kind of stuff that you could be working on if you want to pursue DSP.
So power systems here at Cal State Long Beach, this is the most popular concentration. I think if I remember correctly, at least three-fourths of students in the electrical engineering major choose this concentration. Um, and actually, there's a lot of companies in the area that look for power emphasis electrical engineers. So what can you do with power? If you see these guys on the top the kind of picture on the right, they're working at a power generating station. So what you can do is work on the efficiency, creating these power plants, making them more efficient in generating electrical energy. You can also, if you look at the other picture of the transmission lines, work in transmission. Right now, this is one of the biggest things, biggest problems uh, in this field in the industry is the transmission, because right now the current, no, it's all good. The current efficiency rate is about 80%. So from the amount of energy that gets generated to the amount of energy that actually gets used at the end by the consumer throughout the power grid is about 80%. So that's where a lot of the new jobs are coming in, trying to refine the transmission systems around the electrical grid. Um, you can work on transformers, electrical generators, like I said. Also, electric motors, which is also very big right now, considering electric vehicles and those that market propping up. So I think I got through most of the job opportunities right there. So that's it for power.
All right, next up we have electronics. So what would you do with concentration in electronics? You utilize nonlinear and active electrical components to design electronic circuits, devices, integrated circuits, and their systems. You'll be working with components such as resistors, capacitors, inductors, diodes, and transistors. Some of the job opportunities with this is you can work in broadcast and communication systems. You could also be working on computer hardware and integrated circuit chips. So what integrated circuit chips are, if you guys are taking like 201 right now, it's these little chips, and what you learn in the course is like the AND gates, the OR gates, all these different logic gates. And so what these little chips are is that they basically have that whole circuit inside of that chip, and all these different pins are a different input or output or things like power and ground. So once you get into those circuits, you'll kind of understand the schematic of it a little bit more. But even within those chips, you have, it's just basically a bunch of transistors in there, and that's what you can kind of expect to be working as an electronics engineer. You can go into designing all these little chips, because I know they're constantly trying to like push the boundaries with stuff like that, especially with the chips that go inside your phone. I know they're just constantly trying to put a bunch of transistors in there to make your phones go faster and just provide the most power that it can.
Yeah, they say this is a very complicated industry, but it's also very fun, and the technology is always is increasing exponentially. Like Gerardo said, these components on these IC chips and this motherboard that this lady in the picture's working on, these components are always getting better every year. There's a faster processor, um, a larger storage unit, more storage, and a smaller storage unit actually. And so this is always going to be a great opportunity, or always going to have great opportunities for you in the industry. So this is also a very solid concentration to choose.
Yeah, and there's this thing called Moore's law, which I believe kind of just shows the how I guess you can say how the growth, or how fast we're being able to develop these chips with having a bunch more transistors in there. And I don't know how far back it goes, but data shows that we're constantly kind of growing on this linear scale in terms of how much we're able to actually put into this confined space for a chip. And yeah, like I said, and Dakota said too, it's just gonna keep growing and growing. And this field, like, there's always gonna be developments. There's always gonna be new technology coming out. So if you're interested in stuff like that, I say definitely go for it. And so that's basically all that we have for this presentation. I see that there's a couple questions actually in the chat. So Tarek is asking, are all the required parts for the project in this kit? So yeah, in the free chat on the Discord later on, I can put a link to one of the kits that you can find like on Amazon or something.
Put
And
one right now in the chat box.
oh, you put one. Okay, Dakota. So Dakota
Yeah.
put one right now in the chat box, and I don't know if it's the same one that we got for 186, because me and Dakota were in the same 186 class. But what came with those, which was, like I said before, a bunch of sensors. It came with diodes, resistors, and a breadboard too, which is really important. You can utilize for other classes. So to answer your question, yeah, I think if the one that Dakota posted is the one that I'm thinking about, you should have everything that you need in there.
I believe this one also comes with a lot of IC chips so it kind of doubles for the 201 lab kit as well as 186 lab kit. So I think that, yeah, that's why I posted that one in the chat box.
Yeah. So yeah, like I said, kind of the end of our presentation. And at this point, we just like to open it up for discussion. If you guys have any questions, whether it's about the project itself or just engineering in general. I mean, electrical engineering in general.
Any of our upcoming sessions, or if you guys have any other questions regarding anything, yeah, in the major, like Gerardo said.
One more thing I'd like to add really quickly is that if you don't want to spend the money like on the project, but you still kind of want to go through the program and just learn a little bit more about electrical engineering and the stuff that you can expect, you can feel free to do that too. You're not required to do anything for this program here.
Yeah, and that's why we chose this project, because it is very simple. And if you don't want to buy the components or the Arduino to be able to do the project, if you just follow along with us, you'll be able to understand all the basic concepts. And yeah, you don't really need to do the project to understand it. And that's what we really want to help you guys do. Although it is good for you guys to get the experience messing with the actual hardware components, the resistors, LEDs, as well as the Arduino. And you'll be able to see, if you get a project, let me see, what is this question? If you get the lab kit, you can go ahead and do a lot of projects on your own too. There's some websites, if you just look up beginner Arduino projects for engineers, for electrical engineers, there's, I'd say, hundreds of beginner projects that you guys can look up. So that's why I really recommend getting it, although you don't need to. And there's another question. aviation industry is so if I'm interested in the aviation industry, is control major or is control emphasis the first choice? Now, if you're looking at um, pretty much any industry in electrical engineering, um, is going to you're going to be able to work in any of them with whatever concentration you go into if you want. Um, just choosing a specific concentration is going to allow you to be a little bit more prepared. Although when you get into the workforce, they're going to teach you whatever you need for that job. But I would say control and let's see, electronics. Would you say is good for aviation industry
Hmm.
or mainly controls?
Yeah, from what I know, I think it could be like mainly controls. There's a lot
Yeah.
in that.
So aviation also ties into aerospace. So communications is also good. Um,
It just kind of depends on like what you want to work on
yeah, like it would depend what
in terms of
specifically within
aviation.
aviation.
Yeah. So let's say
Like
if
if
you want to work on designing the plane itself, I would say controls isn't necessarily for that. But if you want to work on the systems within the plane, because I know that there's a like let's say the plane has to maintain a certain elevation and it's not necessarily the pilot who's holding on to this like steering wheel and they're keeping it at that elevation. There's a system within the plane that's helping it manage a certain elevation. So if you're
yeah,
interested in stuff like that in terms of the systems that are controlling the plane, then I'd say definitely control systems is what you want to go for in terms of aviation.
yeah. So that's my choice. That's my reasoning for controls in aerospace and aviation, as well as in electric vehicles. I would want to work on the actual control systems that basically automate that take that vehicle, whether it's an aircraft, spaceship, or electric vehicle or anything actually that moves. The control systems made concentration or control systems engineer would make would implement his knowledge into making that vehicle work autonomously. So if you're looking at like an aircraft, most aircrafts have like a FLIR system, which is forward-looking infrared system. That's a new technology that a lot of control systems engineers are working on, and that system actually allows like for the aircraft to. Okay, cool. Yeah. So
Yeah.
that would allow the aircraft to um, use its radar, spatial navigation, stuff like that. Any other questions?
Well, I mean, if there's no more questions, I guess.
I can't think of anything I want to add
I
right
mean,
now.
I guess just to kind of because we got into 7:30 either way.
Yeah.
Let's see what could
Anything you want to reiterate?
um
Oh, I got a question.
yeah.
Okay, perfect.
So if I want to do robotics, is it controls that I want to specialize in?
Most definitely.
Yeah.
Okay.
Especially if you're trying to make that robot kind of just behave on its own. So let's say
Mhm.
I think a couple days ago, I don't know if it's still available, Michael posted like about the micro mouse.
Oh yeah.
I saw that. So that's kind of robotics and that's kind of going into the systems or control systems because what you're working on there is making sure that you want your mouse to be able to like detect when there's
Okay.
the obstacle coming towards you or something like that. Do you get what I mean? So if you want to work on robotics in terms like that and having it function on
That's
their
cool.
home,
I actually signed up for that,
yeah.
so
So
that's
I'd
cool.
say
Thank you.
Nice. Yeah,
definitely
that's going to be a great
go as much
project.
experience as you can from that. Yeah.
All right. Thank you.